So welcome to the stage, Paul Boris, VP of Manufacturing Industries for GE Digital.
So thanks for allowing me to come and spend a few minutes talking about some of the things that we're working on at GE. This is really going to be an opportunity for me to walk you through the process we've gone through. So my background is manufacturing and operations. I started 2 weeks out of high school, got on a Greyhound bus in Wilkes-Barre, Pennsylvania, went to Tarrytown, New York, GM body assembly plant. That was my co-op assignment, and spent a lot of time in manufacturing, operations, moved into pure technology, moved from technology back into the manufacturing technology space. 10 years with an enterprise software vendor, driving this strategy. And then about 3 years ago, 3 years and a few months, got a phone call. Was not looking to change roles, was not looking to change jobs, but it was a really interesting discussion around this concept of a brilliant factory. And took us a few months, but in September of 2014, I actually started the role as the CIO for Advanced Manufacturing Strategy at General Electric. Spent a year doing that, and we had some pretty good success. And they asked me to take that discussion, not just to our internal factories, but externally as well, and work with the customers in the marketplace. So I think the discussions leading up to this were tremendous. Every aspect that we heard is a piece of the puzzle that we have to deal with. We are a manufacturer who creates software and uses data to drive systems. So when you look at this original paper from about 2011, 2012, somebody talked about billions and somebody mentioned trillions. This paper says $15 trillion globally, right? So let me just see a show of hands. Who really believes that number? Let the record show it's like one person raise their hand. Here's what you need to think about, right? It's not whether I make this clicker more effectively or whether I actually make this clicker with fewer parts. It's whether I even make the clicker, how I move the data in a supply chain. If you think about the flow of data and information across a global supply chain, a value chain, we do a tremendous amount of work that is zero value add in the lean sense. So if you're a manufacturing person, you understand this. If you're not, it's not necessarily obvious. But there are whole buildings where we spend time doing things to try to drive a process that are not adding value to the product. But that's the way we've got to do it, because we've got to collect the data, we've got to report the data, we've got to work with a regulatory agency, whatever that is, right? So I think the number's a good number if we do a few things, and that really comes down to staying focused on the outcome, staying focused on reducing waste everywhere, and quite frankly, how do we rethink an entire process? And I'll show you a couple examples of things I like to talk about on that topic. Something else to consider, and people inevitably come back to the discussion of jobs in this space and automation. I think if you understand the space, if you study it a little bit, you're going to find that the folks who are going to get most disrupted are the folks in the middle of the stack. Right? I just told you that we're shuffling a lot of paper, moving a lot of things that are not adding value. And if a CEO says this is our business model, and the CEO of a machine understands which next action is the right action, and I communicate that digitally, there's a whole lot of stuff in between that tends to fall out of that process. But it's a very unnerving place to be, because it moves an incredible amount of control to the edge. So this is a pretty interesting paper that talks about how our flexibility and how the outcome grows as we lose control of the process. And I think that's not necessarily the way to look at it. We don't lose control, we just give up the type of control we have today. So something to think about in this discussion. So here's an example. I use it a lot. Just if I could see, who's familiar with Uber? Who uses Uber on a, okay, so good portion of the crowd. If you're not, It's a very interesting app. They have their own issues these days. This is really about how they use the data. So in 5 clicks, I start the app. I actually, these are screens from a trip I took recently. It says, look, at the bottom of that, I know where you've been the last couple days. You don't even have to tell me, just touch this button. And you can see it's our corporate office in San Ramon, a couple restaurants that I've been to. It'll actually give me the option of picking the vehicle in the supply chain, the way I want to move. It's smart enough to know that it doesn't know exactly where I am, and it gives me the opportunity to dial that in. So unobtrusively, it says, hey, I'm not quite sure. Can you just clarify this for me? Are you at the restaurant or are you at the hotel? And in the 5th click, it's actually telling me who's coming, when they're coming, what the vehicle is, what the vehicle registration is, the name of the person, and that they've actually, they're just completing another trip. That is a digital transformation. If you've heard the term digital transformation, that is a digital transformation. They are a supply chain company. They're not a ride-sharing company. They bring you vehicles to drive you around. They'll bring you food now with Uber Eats. I sat at my desk a year and a half ago, and my phone chirped with an Uber message. It said, the Christmas carolers from the University of Michigan are raising funds. Would you like them to come and sing for you at your office? Right? So imagine going to your boss and saying, I got an idea for an app. Let's build an app that brings cars. They might as well bring food while they're at it, and let's do Christmas carolers, right? It's not even logical. What they do is they use legacy infrastructure, and they actually align the consumer with a demand across that infrastructure instantaneously on my device, make it easy. When I get off the plane, I don't even go get a rental car. I fire up the app, I have them come and get me. The rental car agency thinks their version of digitization or digital transformation is like this web page. They send me an email, so instead of walking off into their rental car agency and looking up at the board, I look down and I see what slot I'm in. Why don't they bring the car to me at the terminal? I don't want to ride 45 minutes by the time I get to the car, get out of the gate, everything else. I don't want to be in line behind 22 other cars. And you can see how it's gutting the business. This is a web page from the San Ramon Taxi Association. I don't even know how to navigate that page. I'm sure I could figure it out. I'm sure it's not 4 clicks. Your left side, Uber, is a digital transformation. The right side is digitization. Don't get trapped thinking if you're doing what's on the right side, you're transforming. You're not. Let me shift gears a little bit and talk about this concept of machine learning and how this data is going to be churned and used. We talked about all this data coming in. Google trained a computer in 10 minutes to say, just follow the number at the top, make sure the ball keeps going back. We're starting to teach computers to learn the way children learn. Within 2 hours, which is pretty cool, the machine learned that what it really needs to do to play probably as well as I've ever played. Who's played Pong, right? Show your age? Okay, good. Within 4 hours, the machine figured out the trick to playing Pong. Drill a hole up one side and let the ball do all the work. Right? It got connected to the data, it started to listen to gain insight, and then it actually started to optimize the entire process by itself. And that's awesome, but there's a lot of stuff in our way from getting to that point. Let me tell you what I think is holding us up. Andy McAfee did a great presentation at one of our events, Minds and Machines, a couple years ago. And his group did a study of studies. And this stats on the lower left talk about the expert versus the algorithm. So the algorithm, you can trust it 94% of the time. The expert, only about 54% of the time. In most manufacturing and industrial companies, we really only use experts. And those aren't the experts in the world. Those are the experts associated with that line that showed up today to talk about that process. So we want to become data-driven, and everybody pretty much knows this. I'm not telling you anything you don't know. We should be more data-driven. We should put more systems in that are data-focused, that tell us the right thing to do. But that doesn't explain why we've gone from 4% year-over-year productivity growth to 1%. Not we, GE, we, the industrial world in general. It's not logical. Part of the problem, a large part of the problem, in my opinion, is that we've created this nest, this rat's nest of different systems and silos And we'll share these slides if you want to see them more closely, but that's just all the different systems in a plant. We work with companies that have 10,000 different systems in their manufacturing setting. And what they really don't have is 10,000 different systems. They have 10,000 different ways to view the data from the machine, material, manpower interface that gets communicated out to the customer, or requirements for the customer that comes down to the machine. That line scribed lower left to upper right, think of that as a digital thread. If I can hook to the machine, if I can hook to the material, if I can hook to the person, and then just listen in on that signal, I would have different views of data. I would have kind of what Uber did, where they just said, I'm going to look at the roads, I'm going to look at the cars, I'm going to do all these types of things. Now, every circle around a bubble is an interface, writing code, making sure data is in sync, making sure there's no latency, making sure there's no errors. Right? When people are talking about all this great data we're going to collect and how that data is going to make it up into the enterprise, it's got to go through 10 miles of broken glass to get from system to system to system. And I'll argue that the upper left of that slide, that's why we're taking one step forward and two steps back. More digital, more technology, faster into plants, lower productivity, doesn't make any sense. Part of the issue is, I think in the space, we need to take folks who understand the manufacturing and the industrial space and drive a whole different conversation. That's really what we're focused on at GE Digital, is saying, look, if we make things for a living, we should be able to take those things and move them into the marketplace more effectively using data. If we do that ourselves and test that internally, we should be able to do it for our customers. We should be able to help them do it for their customers. Because you don't want to be in a space where you're an excellent, highly trained person who doesn't understand the mechanics of some very fundamental things.
We are the premier engineering and science institution in the world.
Do you think you could light a bulb with a battery and wire? Do you think you could light a bulb with a battery and wire?
Yeah.
Light a bulb with a battery and a wire. Maybe.
Yes.
All right.
Definitely.
Do you think you can light a bulb with a battery and a wire?
Battery and wire? Well, yes, why not?
Okay.
Definitely.
Okay, can you do that?
The interesting part about the batteries and bulbs question is that people always predict that they can do it. Students say, of course I can do this.
Any hints I should have here?
Teachers say, of course my students can do this.
Ow! Do you know why that didn't work?
I have no idea.
So I don't know if that's more interesting or frightening, but those are engineering graduates. Now look, I'm not making fun of them, and that's not the point of this. The point of this is, if you've not spent time in a practical environment, it becomes very difficult to take things that seem completely logical and then move them into position where they actually work. And this is what we're seeing a lot in this industrial internet space, where someone says, because I can turn my lights on and off at home, because I can get a signal to my smartphone that the garage door opened, I should be able to consume this data. I should be able to create a new platform. We've found that just frankly doesn't work. So let me shift gears in and talk about what we're doing, and I'll talk about some very specific examples. And hopefully I'll leave about 5 minutes for questions at the end, so if you're thinking of something, that'd be great. So this concept of the brilliant factory, think of what we saw when we saw the pong paddle going back and forth. Just tell the machine, listen, and when you listen, I want you to develop some insights, and once you develop insights, I want you to tell me the things that we should and shouldn't do. Most systems go into industrial environments today where we do, in an earlier slide, I said the RFP is dead. We take a fastworks approach. We don't bring everybody together, again, all those experts, and say, what is it you do? What are the rules? How do we write that in code? Let's put that in. Because here's what happens, right? I'm running an operation, I go to a facility, and I see something running, and I go, I need one of those in mine. It's been in for a couple of years. It's probably stuff that's 2 or 3 years old. I bring it back to my team and I say, let's now do a year-long evaluation. We're at year 4. Let's do an 18-month implementation. We're at year 5, maybe year 6, and we get the opportunity to turn on something that's 5 years old. In a market space that's changing in like IT years or like dog years now. 1 year is like 5 years. So we're saying, what if we actually just start to listen to all these different signals, if we start to understand the variability? And this doesn't mean you can go in and just start ripping out all those bubbles in your plant. You've got to overlay on that and say, look, people have to continue working. You can't come into an operation and say, this guy was awesome. Stop, everybody stop what you're doing, we're gonna put in one of those. It would be a disaster. You have to marry up with where the process is, start listening on new channels, start understanding and ingesting the data, and then start doing something with the data. And this really becomes that answer key for what we've done. So you remember where you used to fill the bubbles out on the tip? I'm really dating myself. You fill the bubble on the test, you lay the answer key over it, what's right, what's wrong. This is what we found, and frankly, a large portion of this is missing. I'm only going to talk about the things that we see are critical aspects of driving the industrial Internet of Things. In the center, you've got a lot really built on the cloud foundry tools. Don't rebuild what's already been built and what does well. But in reality, if I look at this table, the industrial Internet needs one that looks like that carries 10,000 pounds. If you're talking about a terabyte of data coming off a jet engine in flight, a pair of jet engines. Right, somebody mentioned earlier about some app that said, it sounded like a guy, I was in the back, was 3 months pregnant. You know, a false positive on that app is just maybe gonna upset someone. A false positive when you're flying across the globe is a much different scenario. You have to be able to handle different volumes, variety, and velocity of data. So how you harden that up for the industrial Internet of Things, not the Internet of Things, which is more consumer grade. To the left of that, you see the edge. I want to listen to sensors, I want to listen to machines, I want to listen to, this is the 4th industrial revolution, allegedly. We have machines that have been around since the 1st, I think. How do you connect to a 60-year-old hobbing machine that has no automation on it at all so that you can start to glean data? Right, so you've got this machine that sits at the edge, a box, a kernel of capability, a kernel of what sits in the middle that is in sync. So if I create an asset in the center and I say, this is what all my hobbing machines look like, I can push it to the edge and then I can keep them individually serialized. I can do the updates globally. And then I secure at the edge, because we've talked about security. If you don't understand this space, most people don't, Google German blast furnace hacker. That's all you need to Google. Somebody deposited malicious code trying to get to the office network and physically destroyed $1 million piece of equipment. We cannot afford to have that happen, so we have to implement capability and protocol. We couldn't find it, so we're teaming up with a whole bunch of folks to build this out at the edge. Now you keep the edge in sync with the cloud, and now you've got a big brain, little brain type scenario, right? And I know I heard the 5G discussion. I'm excited for this stuff. I'll tell you, it will be a while before industrial companies take millisecond resolution data on millions of sensors and pass that on a wire to the cloud. You go into regions in the world where you think they get bandwidth for free, they're worse than we are. You have to retain some locally, take the things that are of interest, move them to a position where you can run that machine learning algorithm, and you keep that there, so when you say, I've found something interesting, I want to drill into the millisecond, you can get back to it. And when the big brain then optimizes and says, hey, instead of these 10 data points, drop 5, add 3, and get these 2 in nanosecond resolution. You've got to have all of that working together. And because this is service-based, now you have something that you could scale. What's the piece I didn't talk about in all of this? On the right-hand side, the UX, what people see. If you have ever been in this space, when you do an RFP, everybody trudges in to show you how cool their user interaction is. Show me how I open an order. Show me how I complete an order. Show me how I do this. Show me how I do that. And you type it in, and it's being done by people who are professionals at making great UX. I don't care what it is. All of the rest of this plumbing and hardware and hard work has to be done, and then surface it, in any number of dozen different ways. The thread really runs from the design, the concept, all the way through field and service. If you think about what we do, we take a device and put it into the field for 30 years and maintain it, right? And who's heard IT/OT, right? The convergence of IT/OT. I talk about ET/MT/FT, engineering, manufacturing, and field service. If you think IT and the plants don't talk, you ought to hang around the engineers in the design shop, the manufacturing folks, and the field service folks. They don't even know that you have a business in that space, let alone communicate across it. You're not going to get to the $15 trillion if you can't create an unbroken thread, and on that thread you have this concept of a digital twin, kind of the genome of the device. Now, one thing I want to talk about here, everybody's got an opinion on this. Something to think about is that that twin can be very low resolution, a few pieces of data that then grows in resolution over time. You can start very quickly by saying, is it a filling machine on a beverage line? Is it running? How's it running? What's the amperage on the motor? That gives me a feeling of how the network runs. We have over 600,000 twins deployed, from parts to components to whole machines like a jet engine. This is what we're driving, and this is where we started back in February of 2015. I was about 4 months in. We went to one of our plants in Greenville. They make gas turbines. We did this process we call FastWorks, which is basically diving in the trench with the customer, figuring out what they need, build it very quickly, and figure out how to either kill it, fix it, and drive it forward. And at the lower side, you see our digital thread hub, the digital hub in Detroit. I ran that site when I joined GE. 45 people showed up, and 2 of them worked for me, because everybody got energized around a process that said, we think we can do something differently in a plant, and we could start to deliver something. And within about 6 weeks following that, we had a new set of technologies that were being deployed into plants. We had new plants that were assuming those technologies within 3-4 weeks after that and driving it across our entire supply chain. So Greenville actually has a whole continuous improvement process: energy management, machine health, process optimization, and consumables. That's the 4 areas of primary focus they have. And you remember I said the UX? I don't care. I really don't. Every one of those panels looks different. And there are people who spend their life trying to say, we need a harmonized UI. We don't really need a harmonized UI if the operator who's looking at the lower right is never going to be the maintenance mechanic who's looking at the lower left, number one. Number two, if we can harmonize the back end, the plumbing, if we can get the digital thread running, we could take this stuff off and drop something new on it that's even better. And I'll show you some really cool stuff that we're working on. But what they did is they took the fundamentals of that operating system we call Predix, it's our offering around the industrial internet, their continuous improvement process. In this case, they're looking at a maintenance shop, a wall of monitors in the maintenance shop that grabbed some sensor data, married it with some enterprise data, and created a small UX. Another team actually looked at energy management. They went to the roof. They were actually going to add chillers on the roof. It's an air-conditioned plant, 2.5 million square feet. That's a lot of money. It's never cool enough, and it's too cool. And what they found is by monitoring the data, they actually took chillers off the roof and improved performance across the entire facility. Counterintuitive, that's what they did. They delivered a next-gen MES, manufacturing execution system, again off of the same platform. Here's another facility in Grove City, Pennsylvania, locomotives. So I gotta tell you, I have like the coolest job there is if you're a manufacturing person. I get to see these processes. This is where you take a locomotive that's been on the rail, you bring it back, you tear it down to the engine core, strip it down to all its parts, lay it flat, clean it, inspect it, put it away, pull it back out, build another engine refurb, send it back into the field. Who knows what MES systems are, manufacturing execution systems? These are the systems that tell you how to do the things you should do on the plant floor. And they typically, because we write all the rules, instead of listening and then observing, we write the rules, they tell you to do the same thing every time. And the engineers said, why are we tearing these engines apart? There's components on there that have been replaced in the field like weeks ago. It doesn't make any sense, but that's what the system tells you to do. So now by listening to the data, and what we listened to was what the execution system said, how did this device perform in the field? And if you look in the upper right, you see some green and blue. It said, don't touch this, it's fine, unbolt it, touch up the paint, test it, and put it away. And the other ones got stripped down. We spent minimal dollars and delivered millions of dollars of gains. At the same time, folks in the plant built applications that, quite frankly, if you took to a product management team, they'd never use. Everybody in the company wants it because it serves a purpose. How do you allow the creativity in the teams, not say, I'm going to tell you what to do, but say, how do we leverage you to build new technology very quickly? Here's one of the technologies we'll use. I actually sit on the board of a company called Vuzix. That's their devices on this slide. There's other devices like this, HoloLens and others. I'm not going to get into the debate of why one's better than the other. But we took it to an operator who was putting together a cabinet in the wind turbine business. First time in their hands, said, let me give you data delivered right to the eyeball, and you can see what's happening. This is the first time the person's used this technology. They got a 34% improvement in performance. And that doesn't include what happens behind that eyepiece when the engineer gets a change, has to route it through somewhere else, has to hand it to somebody else, has to print it somewhere else, has to move it somewhere else. So we work with companies like Vuzix and Upskill and the plants, and we say, what if we try this? How could we roll this out? If you look to the left panel, this is some of what we're pulling together. So that's a 3D printed little model of an engine core. They're looking through an iPad, and they're actually seeing augmented right onto that space the parts that they're of interest. You can see a red line, probably from the back, that says there's a device that's a problem. Don't touch the green one, touch the red one. And by the way, when you're looking at the red one, what if I could just tap and go into the field, all of that data that we needed, and not get all of it back, but get the right data for that asset at this time for this particular process. I've got another issue because now I've got maybe a recall or some remanufacturing that has to happen on certain portions of that. I've got some piston assemblies that are underneath those heads that have to be addressed and have to be taken out, repaired as part of a recall. Right? So I've given my operator, AI, artificial intelligence, I think AI augmented intelligence. Give your operators X-ray vision. Put the data glasses on. If I could put the data glasses on, I'd catch somebody on Facebook, I'd see somebody texting about where the kids are, I'd see somebody diligently taking notes, whatever. But the data that surrounds us is now unlocked for us to start to do some of that machine learning on how we want to drive it. I added this piece on the right-hand side because that stuff looks like Star Wars on the left. This is a $15.99 children's toy at the Disney store. 15 bucks. This is, the technology is moving forward. Now, again, let's go back to the beginning. The reason we don't do more of this is because all those bubbles, all of the problems. I got to do another system. I got to do another RFP. Who does this? I bet you there's 1,000 companies right now doing RFPs and projects around wearing data glasses, and they don't even know how they're going to get the data to the glass. They're putting the cart ahead of the horse. So start with a vision. Start to understand what it is to be an industrial, a digital industrial, to use the industrial Internet of Things, and exploit the ecosystem. That first slide I said on 5 a.m., 5:45 a.m., were friends from other businesses that just came along because they wanted to help, right? Create a value proposition from that vision that says, what's the customer going to get for this specifically? And how can I span the value chain in order to do that? And then get into the tactics. You're never going to start with the tactics and move up into a vision. So I've run right up to the time. I think maybe if we have one or two questions, I don't know if we have any. There's microphones here. Anyone, any questions? Did this help understand what's holding things up? So I think we got somebody here with a question. Yes, sir.
One quick question. So you said that you had a difficulty finding, standards for the protocols of the community. Has there been anything you've driven that's starting to show up in the public domain, or is it still all proprietary to what you're doing?
So the question was around standards and whether it's proprietary and what we're doing. So first thing is standards are standards are standards. Everybody's got one, right? We're really not, we're kind of driving it from the use case and then having the standards pull through. The things that are out and available are things like Predix and the operating system for the industrial internet, the solutions we built on that, and the partnerships we've created. So there's a whole set of solutions that are available right now: asset performance management, brilliant manufacturing, Predix Edge, Predix Machine, all kinds of things that if people have questions, I'll hang around. We can talk about it. The standards, I'll tell you this: Pennsylvania, I just saw on the news, all the Easy Pass lanes are shut down because they're taking out. When you go through Easy Pass, there was a red-green light that said red, hey, you're not paying; green, you're good. They're taking them out because it's against the law to have that light. The standard says it's against the law to have the light. They've taken them out, and now when my wife goes through and I forgot to put the Easy Pass in after I cleaned the car, 90 days hence, I'll get a $75 fine, and I've got to spend 2.5 hours figuring out how to clear that. Right? So I don't know, some standards are awesome, others, let's just pull them along. Anything else quick before we go? Hopefully this was helpful. Love to chat with you if you've got some questions that you want to talk about one-to-one. The opportunity is enormous, and the real issue is if you're not getting started right now, it's going to pass you by. You're going to miss it. So thanks very much, folks. I appreciate your time.
All right. Thank you to Paul for that excellent presentation. Just a few quick programming notes. Expo floor is open. Lunch is served immediately on the other side of this pipe and drape. We've got some vertically focused content streams that are going to be kicking off upstairs. There's signage out there to direct you, and we'll be back on the main stage at 1:30. And Threadgills, 6:30 tonight, right down the street. Come check it out.